And welcome to Ladyada.
Hey everybody, and welcome to my desk. It's 7 o'clock. That's hacker o'clock today, because it's heckin' hot out.
Wow.
So we're indoors doing electronics, staying warm by the soldering iron, which does not give us a sunburn. But we do have a bunch of stuff that we worked on this weekend, staying cool indoors. Mr. Ladyada, you also have some news and updates.
Yeah, so if you watched the show and tell, or any of our social media channels, or really anything, you would have noticed that we are working with Adam Savage and friends to help get the word out about Silicon. It's a Comic-Con, and there is also the Savage Makerverse. I put the disclaimer everywhere always because that is how you need to be and should be. We make no money on this. We have no agreements with them. We just miss Maker Faire in the Bay Area, and we want to help get the word out. So if you're in the San Diego area, coming up in just a couple weeks, the Savage Makerverse workshops and more. We had Adam on the show and tell. Of course, Adam will be there. We had Jen Schachter, who will be doing a ton of things there. And we had Sophie, who's going to be doing a really cool workshop where you make your own cyberpunk helmets and more. Jay will be there. Also, you know, some makers that you may have heard or seen in the world will be at the Comic-Con too. George Takei, Christopher Lloyd. This is like everything you want.
That's not Phil B.
Yeah, 21 gigawatt. So this is everything you want to do.
Peter Dragon will also be there in costume.
Yeah, and so Phil B. and some of the other free folks will be around. But anyways, I'm going to put a link in the chat. There's a discount code. Adafruit is a discount code. It's 15% off. And again, we make zero money, zero commission. We are just doing this because we want to see makers get together. It's been a long time. If we could fly out there, we would. But since we can't, we're going to help get the word out. So, Ladyada, what is on your desk this week?
Okay. Well, this week, weekend actually worked on two things. One is I'm playing with the new ESP32 builds for CircuitPython. CircuitPython 8 is adding support, like active support, supported support, for the ESP32, the original ESP32 chip, not the S2 or the S3, which we do support, and the C3 as well, but the original one, the one that doesn't have USB native, which is why we kind of never supported it, is it doesn't have mass storage capabilities. It can't show up as a disk drive. But Scott has been toiling away before he goes on a big break for adding Wi-Fi or web workflow. I don't remember which one he calls it, but it's Wi-Fi based, but it's basically a web-based workflow or internet-based workflow, which means that we want to make it as easy to manage files as it was with mass storage, like dragging and dropping files, except you might use a web browser instead of your computer's interface. But there also might be ways of making the file system appear as a network file system. And of course, we can also do the REPL via WebSockets. So really interesting. So I'm testing that out with this Odroid Go. So let's go to the overhead. So let me get out of this REPL thing. Yeah. So okay. Actually, I'm going to turn this off and turn this back on. So this is an Odroid Go. This is a ESP32 based, like, kind of gamer console thing. It was sadly discontinued, but it was really cool. It's made by a company that makes single board Linux computers, but it has the joy pads and buttons, a speaker, a really chunky battery, 320 by 240 ILI display, which means that we have drivers, on-off switch. Some GPIO header up here, so it's kind of handy if you want to connect stuff. And then on the back, you can see there's an SD card, also handy. The speaker connector, and then it's got a ESP32 Rover. This is the version, I think, that has 16 megabytes of flash and 2 megabytes of PS RAM, or maybe 16 megabytes of PS RAM. I don't remember. But basically, it's got like everything. It's chunky because it was meant to, you can run Doom on it, you can load emulators on it. There's also a really great platform for testing out CircuitPython. So, if you want to check out Scott, he's been doing some posts or some deep dives about the web workflow, and he'll be doing, I think he did one on Friday, or maybe next Friday. I don't know. Time. But now there is at the top a status bar, and if you can see, there's a little CircuitPython Blinka. but now it also has the IP address, the current status, and the name of the version name, which is 800 Alpha 1, because I'm running a custom build of this. But you see the REPL as appearing normally, but the new Wi-Fi stuff, the IP address is new. Basically, you load sort of like a secret.py, a .n file that tells it the SSID and password. And when it boots up, we can turn it off and back on again so you can see it. It takes a few seconds, but it says Wi-Fi off, and then, tick, 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 it connects to Wi-Fi, and it gets an IP address. And now it's available on the internet. So once you program it with the SSID, then you can go to your computer and you can connect to it over the web. So let's go back to my computer. So there's that IP address, the 10.0.1.113. So if I go there, this is a web page, and it's like, why is it so like 1985, 1992 style? It's hosted directly on the Odroid Go. So this is like, there's not a lot of graphics and not a lot of stuff going on, because it's like, this is the bare minimum. But it basically gives you information, links, the board type, and how you can get to, say, the serial terminal. So the serial terminal is, as you expect, a REPL that runs over, hold on, I'll shrink this up here. Maybe I'll make the text a little bigger. This is the REPL that also appears on the TFT screen. So if I type in print hello world, what I'm typing here is echoed also on the screen. Do you mind going into the overhead again? We'll have to bounce back and forth a couple times.
Just tell me.
So, if I type in, 1 + 1, you'll see as I'm typing, it appears, and when I hit return. So it's echoed, and also there is a, there's also, if you go back to my computer, I'm just going to do a lot of bouncing. There's also, if I connect to the serial port, because the ESP32 has a serial port, even if it doesn't have a USB mass storage device, it does have a USB serial converter. All this stuff echoes each way. So like I type in here into the UART, it shows up in the web REPL, it shows up on the screen, like it's all cohesive, which is great. Which means you have multiple ways that you can connect to your ESP32 devices, and then if you want to use, you want to get files on it, again, what we like about the mass storage is like drag and drop files, it shows up as a disk drive. That's not possible yet. We're looking at ways of having a network drive, but there is a file browser. So the file browser is also, as you expect, it's a hosted web page. It's very simple, but it does show all the folders and the files, and I can even click on the file and it'll show me the text. Now, it doesn't have an editor yet. Editor, we will have an editor that will be web hosted, but it won't be hosted from within the device. It'll be something that connects the device over like a WebSocket. But you can do simple stuff like make new folders, upload files. So let's say I wanted to upload a new file, and I was uploading some turtle demos. So we did Star and Swirl and Sierpinski. Let's do benzene. Let's do dots. I don't know what dots is. So I can upload, so you can see it doesn't appear here yet. And then when I click upload, there's now a new file called turtle.dots, and it looks like it just does a couple dots. And then any files that are created also would be available here. So if I was doing some sort of data logging thing, that would appear here. Oh, did I lose? Okay. I can also upload a library file. So I uploaded a library file, turtle.mpy, which means that I can, use this to run demos. So for example, let's say I want to run this benzene demo. I can go to the REPL and hold on. I can import, and then I'll paste turtle.benzene. Oops, I think I had a tab in there. It's like, you wanted a tab. I did not want a tab. Oh no, hold on. Okay, So then if you go to, unfortunately the tab set, but I did do the import. You go to the overhead.
Yeah.
And you'll see it's running.
You did it.
The turtle.benzene demo. And then if I want, I can, I can connect to, like, you can't control C from the web REPL yet, but I can do like import turtle dot couch curve, and then, although that I think actually doesn't work. Let's see, import, let's do turtle dot Hilbert. One loves Hilbert, and it'll do the demo. So, basic stuff is working. Like, there is still like more to do. The only bug I found so far is, if you're in a while true pass type of thing, you can't control C from the web REPL. You can only control C from the serial REPL, the UART REPL. Probably because UART REPL has this, like, it's listened to a little bit more, whereas the web stuff is a little bit like you have to, like, get into the core, and maybe the core isn't getting it. Maybe the FreeRTOS thread that's handling the web connection for the REPL isn't getting starved. It's not getting checked off enough. But otherwise, it seemed to work pretty good. And so this is kind of fun. Like, this is, I have this connected to, serial, but it works just fine. Also, if you disconnect it, now the REPL's closed, and I can, let's see if I connect to the REPL. I can do import turtle star. Oops. And I'm now drawing a star instead. So, totally wireless.
Yeah.
Ooh, amazing.
This is cool.
Yeah, it's just like very cutting edge. I just submitted a small PR change just to make the display appear as a native display, but it does work. And what's really nice is because we have added ESP32 S2 and S3, really well. We've done a really good job with that. And through the ESP IDF, I think we're using 4.4 as the version. The ESP32, not that it's easy, there was quite a bit of work to get the ESP32 up and running, but we're not starting from the beginning with the peripherals. Like, a lot of the peripherals, like, just worked. Like, we have to, tweak them, but getting SPI and I2C going was not as challenging because we already had support for this core. So it's kind of a little bit of a step back because the ESP32 is much older. But, we wanted to wait until we had a really good way of interfacing with it. So next steps are we're going to add more boards. We're going to do the alpha release, the beta release, or whatever, to coincide, with or right before CircuitPython Day, which is coming up. And then, if you have an ESP32, we have definitions for the Feather, but if you have other boards you want to add definitions for, we're welcoming them. Please do add them. And, I think we have both PSRAM and non-PSRAM versions up and running. The Waroom and Warover and Pico, which are kind of like they're kind of like definitions that kind of establish how the QSPI, Flash, and PSRAM is connected. So especially if you're using stuff that has those modules, you can, like, pretty much copy and paste our existing board definitions because the amount of Flash and PSRAM and the configuration for the IDF to get those up and running is good to go. Okay. Any questions about that? Otherwise, I'm just going to...
People are trying it out and they like it. They are saying they've been playing along. So...
Yeah, it's interesting. I mean, like, there's just thousands of ESP32 boards, right?
Yeah.
So.
Web workflow could be a cool way to control this planned environment controller someone's working on. And Paul's working on it as well. Yeah, and, you get a chance to talk to everyone live as we build all this and do this. We've had some deep dives. We have CircuitPython Day coming up soon. So, all right. Do you want to do the Great Search next?
Well, I thought I would actually, we're gonna do Great Search. Time I said is complicated. We're gonna go backwards in time for the Great Search, but I'm gonna show off this breakout that I worked on this weekend. First, so this is a Max 17048 breakout. It's a battery monitor, so I've got a battery here, and it's a sense resistorless one, which is kind of nice. So you can just, like, plug in a battery and plug in the load, and there's no since. Whoa, what was that? I think it's my phone. I got a new phone, and it's like beeping. So this is a resistor senseless single lipo battery monitor. And I'm writing the driver for it, and I'm using my FT232H, which I love, to write the driver in CPython. So if we go to the computer real fast, we've got this new driver, which I just finished. So if you are using this chip, I think SparkFun uses it in a couple boards. I think Seed also uses it. It's a low cost, easy to use monitor. They kind of got everything going here, and you can see it can give you the percentage state and the voltage. Handy. One thing that's nice about it is it's extremely low power. So if you want to do alerts based on battery voltage or state of charge, I think this uses like 5 microamperes, very little or even less. So it's great for if you're making something that's battery monitored and you want to let's say you have like a feather or a board that you want to. It wakes up once in a while, takes a measurement, or maybe it's waiting for an event, like a button press, and it wakes up and it takes a measurement and sends data. But you want it to also alert you when your battery gets low. The problem is, the battery will slowly drain. You have to wake up all the time to see, hey, how's the battery doing? What's nice is that this will do it for you in the background, and it can send you an alert, wake up your board and say, hey, the battery dropped below, 3.7 volts, time to recharge it. You can send an alert to the user to tell it, hey, the battery level's getting low. And then, if I plug it into the charger circuit I've got, you'll see it's, the battery voltage jumped up a little bit to 4.05. And there's also alerts. I think the alert I have is... let's see, hold on. Let me open up my advanced demo. I set the voltage at 4.1, so let me set it at 4.0. So you can see. Yeah, so this is it can send you an alert that the voltage is high, and of course the pin is going high as well. And then if you remove it, the alert turns off, and then if you also, let's see if I have the minimum alert, I can set it to alert me when the voltage is too low as well. Kind of nice chip. But how did I pick this chip, and why am I making a breakout for this chip when I have the LC709, my favorite battery monitor? Well, that's a topic for the Great Search.
Okay, let's kick it.
Kick it.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thanks, DigiKey. This is when Ladyada uses her power of engineering to help you, yes you, find what you are looking for on digikey.com. Ladyada, what is this week's Great Search?
You'll never believe it, but this one is a part that's been discontinued,
Oh, no.
unavailable, and so we have to
First
find
time
out
in history.
Yeah,
Oh.
for this week so far,
For this hour.
since last Sunday.
Yeah.
So this week we are kind of humming along, trying to find a good replacement for a part that's about to be completely unavailable. The LC709-203, our go-to battery monitor chip. So let's visit Adafruit, and we'll show this off.
Any chance that battery monitor will make it on a feathery vision?
We don't know. Maybe.
Don't know.
Maybe not.
Let's explore together.
Let's explore together. Okay, so this is what we've got now, the LC709. So this monitor is it's out of stock now, but it's actually not, because it's not out of stock. We just sold a bunch. This battery monitor is quite nice because it doesn't use a sense resistor. It's like about $1.50 for the chips, which means I can make a whole breakout with everything and test it for about $7. The original version had a TDFN part. You can kind of barely see it here, which was really nice because it was easy to solder. Eventually that became unavailable, and now we have to use the BGA part. But the BGA part's not too bad. It's a 9-pin BGA, but the center pad connects to one of the middle pads, so like it's fine. It's basically you're not dealing with, okay, how do I get my pads out from underneath a BGA. The problem is that this part, it's discontinued. It's still available, but it's going to eventually be not available. That said, it was still, because it's just so inexpensive and great, it's still been worth it to use. So, for example, this is what I originally used. It's no longer manufactured, no longer available, and so I was like, well, I'm just going to swap over to the BGA version. Also unavailable, but there is, 18,000 in stock, 19,000 in stock, and there's plenty, and we've been able to order enough to last us many years, so we're actually good for a while. But long term, or if something happens to the inventory we have or whatever, we will have to design out. Or if I'm designing new boards, I'm probably going to design out to get something else, because stuff that's going to end of line is end of line-ier than it used to be. So I wanted to show how I've sourced a alternative. So the price is about $1.60. So that's kind of what I'm dealing with for competition for this part. I want something that ideally isn't BGA, or if it is, not having to use the middle pads, because I really want to stick to some low-cost 2-layer boards. I don't want to have to go to four-layer or like buried vias or plug vias or whatever. Lithium-ion, lithium polymer battery, single cell is fine, and I want it to be I2C. So looking at the options here, I want the battery monitor with 1 cell of lithium-ion, although maybe I won't pick that. I want it to be surface mount. And let's see what they've got. So let's only go for active parts, because I don't want to deal with non-active. Next up, we've got a couple options. Basically lithium-ion, lithium, cobalt oxide, LiCo, lithium-ion polymer, maybe multi-chemistry, I think. Whatever, it's fine. I think, lithium-ion covers everything, but still. Next, for the interface, so I actually had to look up what is HDQ and SDQ. So it turns out those are basically one wire. So I don't want those. So I want I2C and HDQ I2C. I don't want one wire. I looked at the ones that are dash, and those are actually like battery protection monitors. Like they don't have any interface at all. They just like turn on and off the connectivity to protect the cell. I want something it's really a monitor, like not like a monitor to like care for it, but a monitor so I can like query it. Okay, so it pares it down a lot. So you can see like this actually, the LC709-204 is clearly the next generation, but again, I don't like the BGAs, and I don't like the BGAs with the pads in the middle that I gotta do stuff with, because I don't want to have to route around. I don't want to have to get like a 4-4 rule board. I don't want to do a 4-layer board. Lazy. Let me be lazy. Okay, so given that, there's actually quite a few options. So first up, I'm going to do, the pricing is really important to me. Like, there's just no way I'm going to make a board with a $3 chip on it. It basically adds like $10 worth of cost. It has to be like it has to be less than $2. So let's see what is available. And I also want stuff that's only normally stocking. I don't want, if it's not something, it's okay if it's not in stock right now, but if it's something they don't stock at all, I don't want to, I don't want a special order, something I'm never going to get. So actually there's a couple of options, including, of course, that LC709. So this is by price. So you can see, this one's actually quite interesting. So this is the FFG 3105. So this was interesting. It's actually, I mentioned I don't want a battery protection cell. I want something to tell me like the state of charge. This is actually kind of both. It has a unique identifier. It has I2C on it, but it's also meant to possibly control and signal the protection IC. It doesn't have a sense resistor, but one thing that is a little annoying about it, not that I don't have a big problem with this chip, but a little bit of a thing is it only really is an ADC. Like it doesn't have an alert output. It has a chip enable, so it's like there's one output, but that just is like something terrible went wrong. Like you can't really like customize it very much. And if you go down to, the register maps, hold on. Beep, 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 beep. You can do pack. You can read the pack temperature and the voltage temperature. It says cell current, but that actually doesn't work. And there's just user ID, like a battery ID. So it's not really. It's basically an I2C ADC that's extremely low power. It doesn't have any monitoring or alerts or state of charge calculator. So it's not a bad chip. I mean, it's 50 cents, but it's actually kind of not what I'm looking for. So that was cool. I kind of skipped over these. I mean, I looked at the data sheet for these. A lot of these were good, but again, it's I didn't want a 0.4 millimeter BGA if I could avoid it. Also, a lot of these required a sense resistor, and again, I kind of wanted to avoid that. A sense resistor is, of course, going to get you the best, Coulomb counting. You're going to be able to track the current going in and out, but it makes it a little tougher for people to, if you've got a feather and you want to monitor it online, or if you have an existing system and you don't want to get in between the battery, if you want to tap onto the battery but not get it in between, this is more complicated. That said, the BQ series has some good options, and one thing to check is sometimes, not in this case, but sometimes if you're lucky, the middle pin, which in this case is B2, can connect to another pin. So again, it doesn't have to go out, but unfortunately in this case, it is a ground pin, and they're expecting, I think, to have a plug to be on, inside to get to the ground plane underneath, which I don't want to do. So I'm going to skip those, and then there's a whole family of them. The next ones that seemed okay were this one. It's not in stock right now, this TI series, but it was in a package that wasn't. It's a VSON, so at least you can solder to it, without wanting to die. Doesn't look too bad, but again, it does require a sense resistor. So not terrible, but something to keep in mind. But I would I'd look at that because it is inexpensive. And then there is another one from Maxim. This is a fuel gauge. This one does also need R-Sense, and it requires an R-Sense against the ground. It's a low side sensing, which really drives me nuts because I really don't like having grounds that are different. I don't mind if the power voltage, can dip a little bit, but I really dislike it when my grounds are moving. So unfortunately, this one is kind of a no-go. So as I scroll down, there's more of that BQ series, and that's when I basically bumped into the Max 17048, because this kind of is very similar to the LC709203. No sense resistor, runs directly off the battery, has an alert, has I2C. It's pretty simple, and I got the driver working, in a couple hours in CircuitPython. And another nice thing about it, which I thought was nice, is that it runs off of a battery which is expected to be 2.5 to 4.5 volts, but the data pins can be up to 5. So if you're using this with something like an Arduino Uno or some other 5-volt microcontroller, you can send I2C data 5 volts even if the battery is at 3.3, it's protected. So I ended up going with this chip, but I did want to show one more option because I saw this weird chip. So I was like, well, let's look at this. I think it was the LTC. This LTC wasn't too bad. Also required a sense resistor, but there was another one. If I can remember, it was... Hold on. I have it in my... Actually, I don't. So let me actually look up analog devices Maxim and see if I can find it. Was it this one? No, sorry, not analog. It was linear. Sorry. Not this one. Is it this one? Oh, bummer, I can't find it. There was one interesting chip, maybe we'll highlight this, that Linear Tech came out with. And what's neat about it is it actually, the sense resistor wasn't inside the package itself. And it could, like, it did the Coulomb counting, but didn't need an external resistor. Like, it did high side sensing all on its own. I can't find it now, but if I do later, we'll post about it. But the problem is that even though I liked that the resistor, that it was a high side sense resistor on the inside, it had 100 milliamp current output max. So in the end, what I ended up going with was the Max 17046. Benefit also was there's 10,000 in stock. So, you know, I'm ordering basically a reel of these, and I've got the breakout ready to go now. But these have been actually in stock for quite a bit. Like, Maxim's done a really good job of keeping them available for DigiKey. So I'm feeling pretty confident that this is not going to be discontinued in the next 2 weeks. If I'm picking a replacement, I want to try to pick something that's good for like 3 years at least.
Summarized nicely in the chat. Sounds like this week's great search lesson is that at times finding a suitable replacement takes some diving into the details of the datasheets and recommended configuration.
That's right.
Yeah.
Especially with battery monitors, they're all a little different. Like you saw, some are high side, some are low side, some need sense resistors, some don't. Some they have I2C, but check the register map. Does it really give you what you need? But yeah, this one's a good one. I'll probably end up also looking at a high side, a current sensing one as a backup alternative, because the model gauge ones like these, where they try to model the state of charge based on voltage and voltage change, are really funky, but they're a little unusual. They're weird.
All right. Well, Skur has a good pun. It's a real experience, REEL, and then immediately I said, "Oh, we should do a new show, The Real World," where we put 5 engineers in a house and we don't give them parts. Let's see what happens.
They have to fight over the last tube of Atmega 3.
I'm not here to make friends. I'm here to do engineering.
Sounds like Random Hall. Okay.
Naked and afraid of not getting parts. Okay, that's this week's Great Search.
Thanks.
Where in the world is that part I need? The Great Search with DigiKey.
Okay, so all those puns are over.
I'm trying to
Anything else
remember
before we bounce?
No, I was hoping
Okay,
I
let's
could
bounce.
remember the name of that part, but I can't remember it. Was it? Oh, sorry. It's the LTC 337. This was cool. Yeah. So let me just show this real fast on the overhead on the computer. Yeah. This is a really weird. I didn't end up going with this chip, but I did see it. It's really funky. So this is a monitor that has. I mean, like, first off, anything from Linear is always going to be like kind of like crazy and amazing. They make great stuff, and this one was actually affordable too. So it's it's a Coulomb counter with battery state of health, but what's interesting is that it doesn't require any external components. Instead, you have the battery in, and then the system load goes through the chip, and it does like the monitoring like inside, and then like you have like a super cap. It's kind of funky and weird. There's like a super cap, and there's I2C connectivity, and you can like query it. The only thing that's a little annoying is, and you can like change the current limiting output. The thing that is annoying is that the current limit max is like 100 milliamps. So it's like, you connect it up to like a Wi-Fi chipset, it draws 300 milliamps or 350 on connection. You just totally, blammoed it. So not something that we could use, but definitely funky and weird part. So I thought like I'd highlight this as a, sometimes it's not the part I want, but maybe it's a part somebody else could use. If you want a current peak limiting, because that's actually the one thing that most battery monitors for lipos don't do. There's no way to limit the amount of current. You'd have a separate circuit to do that. This one will do current limiting for you, as well as Coulomb counting, state of charge, etc. So really funky, weird part, but check it out. It's the LTC 3337.
All right, and that's the desk Ladyada. Thanks, everybody.